Businesses today have access to a huge amount of usable data, including data from social media and many other big data sources. They use this data for effective decision-making and improving processes. However, to make use of this enormous data effectively and at the required speed, businesses need suitable technology frameworks. Businesses use applications and technology infrastructure to capture, format, store, perform, compute, search, and display a variety and volume of data that can help make fact-based decisions. Typically, trained employees and organizations run several IT applications on servers that leverage dedicated resources, such as memory, disk storage, network, and end-user devices to achieve this. But in case of big data, storage and processing of such large volume, variety, and high-velocity data is a clear bottleneck for a typical dedicated, centralized computing setup. Handling such big data requires a special technology infrastructure. This video will take you through technologies such as distributed computing and the Hadoop ecosystem that make handling of big data possible. It is possible to remember that in most cases, not one technology, but a combination of multiple technologies is required to effectively handle big data. By the end of the video, you should be able to explain the concept of distributed computing in relation to big data. Give a broad overview of the Hadoop distributed computing environment. As discussed earlier, handling the data volume, velocity, and variety combined with structured and unstructured data types needs new paradigms of data management in the areas of storing and cleansing data, processing, search, sort, filter, combine, compute, graph, etc., large volumes of data at extremely fast speeds, presenting real-time analysis in effective ways, facilitating collaborative interaction and quick decision-making based on the analysis and interpretation of the data. All these tasks need to be done efficiently, without leading to any backlog or slowdown of system performance. This is especially in case where data needs to be processed and used real-time. Therefore, to manage big data, it is essential that businesses have the following solutions in place: adequate storage capacity, high-speed computing platform, high availability of computing platform, capability of handling data variety, capability of timely and personalized information delivery. To ensure that these aspects are taken care of, a number of technologies have been invented over the last decade. Adequate storage capacity, use of huge volume, low-cost virtual storage systems to track where data is located. High-speed computing platform, use of multiple processors, low-cost networked computers, and in-memory computing. High availability of computing platform, fault-tolerant systems to tackle redundancy of systems and data replication. Capability of handling data variety, use of distributed computing for handling data variety and handling real-time data. Capability of timely and personalized information delivery through mobile devices, visualization paradigms, and real-time alerts. Of these, distributed and parallel computing and the Hadoop infrastructure are some key technologies. Let's first understand what distributed computing is. Consider a large university. Every year, a huge pool of students appears for entrance tests to seek admission in various disciplines of graduate studies. But it is impossible to include all these students in a single university campus. The university therefore takes up the task of allocating students in small groups to various affiliated colleges based on predetermined quota. It uses the entrance test scores as criteria for allocating students to different colleges. Now compare this to an organization which has a diverse but large pool of business data that needs to be processed and stored. Given the volume, velocity, and variety of this data, processing such data on company IT infrastructure is not an easy job. Now, what if the organization had a system similar to that of the university, whereby it could chunk the huge amount of data in several groups and allocate them to different connected commodity computer systems so as to complete their tasks? Well, this is the rationale of distributed computing, a system which can effectively deal with huge amounts of data. Distributed computing is a method in which multiple computing resources are connected in a network, and computing tasks are distributed across resources, thereby increasing the total computing power. This makes handling of huge data in limited time possible. Now think of the university scenario once again. Each of the colleges affiliated to the university is autonomous. This means that each college controls its own resources, such as the faculty, labs, classrooms, and sports facilities. All students in the college share these resources while studying various disciplines. This is similar to parallel computing, which uses the concept of working in parallel simultaneously. Parallel systems are those where the processing power of a standalone computer can be enhanced by multiple processing units, which can break up a complex processing task into multiple subtasks, and each processor carries out individual subtasks autonomously. When it comes to big data, such systems can provide concrete solutions by breaking down the task into multiple subtasks. These systems not only helps in processing large amount of data in a short span, but also in dealing with latency, or the aggregate delay because of a large number of individual tasks involving a huge amount of data. Another technology that provides an added level of efficiency in handling big data is virtualization. It enables isolation of available resources and services from the underlying physical environment by creating many virtual systems within the same system by using a software program. That was about distributed and parallel computing. Now let's discuss one of the most popular frameworks of distributed storage and processing of big data, called Hadoop. Hadoop is an open-source software platform designed to process large volumes of structured and unstructured data sets in a distributed computing environment. To understand how it works, let us refer to the university scenario once again. As mentioned before, many colleges affiliated to the university help students acquire knowledge in their discipline by using the resources available independently. But the final degree is awarded by the university, irrespective of the colleges the students attend. Similarly, Hadoop uses a mechanism called MapReduce that assigns tasks to different networked systems and then collect the results and aggregate or reduce. This simple programming model lets users create and run applications on distributed systems fairly quickly. It distributes data efficiently and automatically across machines, which exploits the parallel computing principles of CPU cores, finally allowing various data analytics, visualization, and reporting on the data using specific tools. How does Hadoop do this? Let's understand in detail. Hadoop breaks large amounts of data into smaller, manageable chunks and distributes them to many computers in a manner similar to the university assigning various students to multiple colleges based on their scores in the entrance exam. Hadoop can keep track of the data by sending a job code to all the servers that store the relevant piece of data. Once the distributed computing is done by the individual computers, the data is collated for a comprehensive result dataset. Going back to the university scenario where the university management wants to analyze the student performance in different disciplines, every college will provide data to university management. In Hadoop environment, each server would search its records and return the ones that match the query. Hadoop would then put together all these sets into one result. However, a question may arise here. Among the technologies, why is Hadoop the most popular? What are the advantages of adopting the Hadoop framework? 1. Hadoop keeps multiple copies of data that can be used in case of server failure. 2. Hadoop is designed to scale out with ease by adding data nodes as per requirement and can store data in any format. 3. Also, Hadoop is quite inexpensive. In most cases, the cost per terabyte to implement a Hadoop cluster is cheaper than the per terabyte cost to set up a tape backup system. Now that we have discussed about some of the key technology frameworks of big data, let's evaluate your understanding so far. If you selected option C, you are correct. Distributed computing systems are a collection of independent, autonomous, interconnected computers that can coordinate and cooperate with each other to accomplish a task. Now that we have come to the end of the video, here is a quick recap of what we just learned. Businesses need special technology infrastructure to handle big data and use it for effective decision-making and improving processes. Businesses need solutions for adequate storage capacity, high-speed computing platform, high availability of computing platform, capability of handling data variety, and capability of timely and personalized information delivery. Distributed computing is a system that can effectively deal with huge amounts of data. It is a method in which multiple computing resources are connected in a network, and computing tasks are distributed across resources, thereby increasing the total computing power. Parallel computing uses the concept of divide and conquer, where multiple processing units break up a complex processing task into multiple subtasks, and each processor carries out individual subtasks autonomously. Hadoop is an open-source software platform designed to process large volumes of structured and unstructured datasets in a distributed computing environment. Hadoop helps the twin challenges of data storage and access while working with a huge amount of data. Hadoop breaks large amounts of data into smaller manageable chunks and distributes them to many computers. Hadoop distributes data across different servers using a mechanism called HDFS, Hadoop Distributed File System. Hadoop uses a mechanism called MapReduce that assigns tasks to different systems and collects the cumulative results. Hadoop can track stored data, keeps multiple copies of data to ensure recovery from failures, and it is inexpensive.